All right. So the progression. Yeah. Now we have everything in one package, including the full history of any time you've used this pipeline using Ada. And that is the entire stack of everything that you might want to use as we're discussing today, one at a time. And I'll repeat, tools are not mutually exclusive. Combine things together. You can have Ada tasks that use GNU Parallel or even Signac under the hood. You can bring in other tools that weren't mentioned today, either from like sort of the simpler, easier side or the more complex side. You should be able to recognize the sets of features and requirements and maybe services if you look at new tools that weren't discussed today. Like, oh, there's the part that adds the Python API. There's the part that handles asynchronous running. There's the part that handles pipelines and dependencies. There's the part that separates orchestration and user control from workers that are actually managing the task operation. And that's going to give you the language and internal vocabulary that you need to actually start evaluating tools on your own and being able to search out more things on your own. And also map that to the requirements of the project that you happen to have sitting in front of you at the time. You don't have to over optimize for scaling that you're never going to do, but you may want to prepare in advance for, I'm going to need the history of what I'm working on 2 years from now when it's time to write the final report and submit it to Bethesda. Okay. That is the end of the prepared presentation content. Thanks for sticking around. If you've stuck around, 11:37. I will remind people that the link exists for the survey that we pass out to people on this. That is in the Q&A document.
Let me put it one more time.
Yeah, you can redo the links. I will point, I had a long list of things that I wanted to do to prepare for this seminar, and I did get through all of what I considered minimum viable, which is multiple runs through the examples myself to check that they work and polish on the slides. There is content in the repository that is still in like a draft form that I didn't have time to actually go through and validate yet. And I think I might keep working on that even after the presentation for use in like writing nurse documentation. So there is like some installation resources for different tools. There is some information that has more detail about, okay, well, what if you want to actually move this to spin? That I've not had the chance to go through and directly validate. It's still in the draft. It probably has errors, but it is going to be shaped like something that will help you if you get to the point that you actually want to be deploying things on a spin. If you have further questions beyond the span of thing about using these tools, I can definitely be reached by submitting a nurse help ticket. If you have a wordful question about one of these tools and you ask for me specifically, then that can be routed to me, and that's a way. I think we still have the consulting@nurse.gov email address that will make like a guest ticket. So if you don't have a nurse account, you might be able to use that. My email address is like my work, warndt@lbl.gov. If somebody outside of having a nurse account has a question, then I might be able to answer it, sent to there. Does anybody want to ask any questions using their voice or anything like that? I mean, we are fully able to have a conversation at this point, if anyone is interested.
I have one question.
Yeah, go ahead.
Yeah, so I was wondering about this Slurm integration. So let's say, each of the tools has some sort of, Slurm integration pieces. And basically, it seems like how does it work? Even, for example, the Maestro is generating the Slurm code so that, when Slurm takes care of the dependencies, or, Maestro takes care of the dependencies.
So the interface that goes directly into Slurm, and this might be used by people typing on their terminal or by workflow management tools, is to write one of these Slurm submission scripts and then use an sbatch command to pass that script to the Slurm scheduler. And that's what's happening under the hood when a tool has Slurm integrate. Like Slurm doesn't provide an API endpoint for users. It's all going through these console commands. So when you specify the details in like a Maestro YAML file, you're telling it the bank string. So that's your nurse project. You're telling it the quality of service you want to use. That's regular or debug. You're telling it whether you want CPU or GPU. Maestro takes that information in its own format and uses it to write the Slurm expected format. Sbatch -- QoS equals regular, and on and on and on.
I see.
Enough to build a fully specified submission, and then Maestro is the one that's running the sbatch command. Or Maestro would be running the sbatch command, or a Merlin worker would be the one running the sbatch command, or the IDA daemon might be the one running the sbatch command. So we're chaining together different interfaces here. And the kind of the reason that things get designed like that is many of these tools don't want to be limited to only running on Slurm. They might also want to run on Flux, which is a Lawrence Livermore scheduling tool. And Flux has a completely different interface for how you submit a job and what parameters and how you define them. So you need to be able to specify in the language of the workflow scheduler YAML, how do I pass those things to Flux instead of Slurm?
So then if we want to have, this, Maestro for another types of scheduler, I think, that maybe then like Maestro has to change something inside, because I think that
Maestro has different components inside that are written to do that plumbing for things that they support. Maestro has a Slurm component that knows the mapping of inputs to how to talk to Slurm. And it has a different component that knows the mappings of how to pass job specifications to Flux.
Okay.
And that'd be something to look at in the documentation details for each tool. Which schedulers can this talk to natively versus which things might I have to write the script myself and rig up like the command block with an sbatch in it instead. So it's sort of how much of the load can the workflow manager do for you versus how much of the plumbing to the scheduler do you need to do yourself.
I see. Thanks a lot. Much appreciated.
Yeah.
Thanks.
Scott?
Yeah, so I really enjoyed your presentation. Thank you very much. And I like the way that you laid it out, going from GNU parallel all the way up to the super advanced Ada.
Hey, fill out a survey, please.
Yeah, I will. So, but unfortunately, in the official nurse documentation, the only tool that you presented was the GNU parallel.
I want to get this done, and I ran out of time before the deadline. I am going to keep working on that. All of the information I did, the preparation, research, testing, etc., this is going to be used to add more sections
Okay,
to our documentation. So it
fantastic.
is coming.
Okay, great. And now that I mean, this GitHub repository that you posted looks like an amazing resource, especially since it has examples. So that's super excellent. Could you just, if you have any familiarity with Fireworks, could you sort of, on your spectrum of workflow tools, where might you place Fireworks?
Okay. Fireworks, my understanding of the history is that the materials science community adopted Fireworks in a big way for a long time. It is very good for throughput workloads. So it is going to be running as a service in process form. Oh, no, I'd have to pull out my spreadsheet to look at what the back end is for Fireworks. But it is, culturally, it is good at throughput workloads, which is large numbers of small tasks.
Mhm.
In the material science community, they have been moving towards Ada from Fireworks.